So data types, and that's the main focus that we're talking about. So we have structured data, which is the traditional sort of data where you have tables, spreadsheets, or any sort of data that is structured in columns and rows, and these are quantifiable information. While big data, which is the unstructured data, and it's defined with 5 dimensions, which we'll discuss in a second. So we have predictive analytics, which anything which comes beyond the present line, anything in the future, has 3 types of has three main types: supervised and unsupervised and reinforcement learning. Supervised learning is basically you have a data set which is tagged, and when I mean tagged or labeled, is if you want to do a regression, you have say you want to predict the house price in a particular area. So you have all the house prices or all the house transactions that happen in that area with a tag, which the value which is sold for, and you can use this information to train the computer based on real input. And classification is it's basically classifying things into categories, whether it is so if we talk about images, for example, you can classify that an object in an image is a cat or a dog, and that's how the classification works. It also works in structured data, so you can predict there is a 0-1 classification where you can have whether the project will finish on time or not. So if it's going to finish on time, it will report true. If not, it will report false, with giving you a precision value. The unsupervised learning is a bit different. So you do clustering, and clustering is basically it has like a big data, and you don't give it any labels for this data, and you ask the machine learning algorithm to cluster or to group them into different groups. That's used heavily in commercial applications, like in Amazon and any other retail thing where they do. Netflix is one good example of that. So they cluster the users or the subscribers in order to do a recommendation for them. So when you go to Amazon, you bought a book, they will tell you that if you bought this book, you might be interested in that book. Most of the time, it's relevant to me. Some people they claim it's not. Reinforcement learning is a sort of a supervised learning, but it differs from the way that it works. So supervised learning is working on a way to minimize the error. So I will show you in the next graph how that works. But in reinforcement learning, it's more like an award system. So whenever you do something wrong, or whenever the algorithm is achieving or reaching the target, then you give it a reward. I would say that if you want to think about reinforcement learning, think about Super Mario, the game. So if you're playing Super Mario, every time you take one of the mushrooms, you grow up. So that's exactly the way that you do reinforcement learning. Regression, and I've mentioned here linear regression, but there are different types of regressions. But regression is basically, if we use the house example that I had before, we have all these house prices, and you can see that there is a correlation between these house prices, that whenever the size increases, the price increases. Basically, the regression will just have that line, straight line. The linear regression will have that straight line with one condition, that the sum of squared errors, which means that the sum of all the differences between these points and the line, is equal to 0. And that's where you minimize the error, or you minimize the loss. There is also nonlinear regression, and these are quite good shapes of them. So if we try on the left-hand side, if we try to make a prediction using linear regression, that would be the result. And I think it's quite obvious that it's not a good predictor. But we can match it with a line in the other shape on the right-hand side, and that would be giving us a much more power or good prediction. So that's, as you can see, that's 95% confidence level of doing predictions. However, we need to be very careful when you do high level or high degree of regression, not to overfit, because if you overfit the data, you will have your training set fit is quite good, while when you try to generalize your model, it will not work outside. That's an example of the classification where you have the classifier, it have this function, and you predict whether it's 0 or 1. It is something like the example I mentioned about whether the project will finish on time or not. So anything in blue will be, yes, it's finishing on time, anything in red will not be finishing on time. There are a lot of variables that you need to consider how you build your model. And that's showing, you cannot show it on a graph because usually it's not like 1 dimension or 2 dimensions, or it can be hundreds of dimensions, which there is no visual way of presenting it. So for simplification, we just consider 2 variables just to make it easy to visualize. So big data has 5 V's, or 5 different variables or attributes, which is volume, so the volume of the data that we store. And some people, they say that the volume of the data is considered big data when you cannot store it on a physical computer. Velocity is the speed of how data is transferred. And I was reading an article today that every minute there are 400 hours of videos uploaded to YouTube. So the amount of data that we can have from YouTube, if we can analyze and make the computer understand videos, is massive. Variety. So as I mentioned before, the big data can be images, can be audio, or can be any other source of information or data. Can be geospatial data coming from a GIS system, or any other sort of system that the computer can understand. There are a lot of work to be done on understanding different types of information and data that are coming from different sources. So images now is quite good. The computers are quite good at understanding it. Text as well. I think videos is a bit of a challenge that we will see some examples later. And the variability of the data. So the data is usually variable, and having a large variability that gives you a better way of predicting and doing inference into the future. The value. Are we collecting this data for a reason or not? What is the business case of doing all this work? Is there a valid case that we have to collect all this data and do the analysis and do the analytics for it? And veracity. Veracity is about whether the accuracy of the data that we're collecting is good or not. And if you have bad quality data that you have no accuracy in this data, then all the predictions that you're going to do will not be useful. So the big data analytics, I'm just mentioning some examples. That's not exclusive by any means, but these are the hot topics that currently run. So we have computer vision, and the computer vision is how the computer can act like a human being, how having an eyes that can see things and then can do and understand these things and summarize them. Natural language processing. In construction, we have a lot of information that is written documents. So we have plans, processes, procedures, standards, all these are written documents. So can the computer really understand these documents and make use of that understanding or not? And audio recognition. And I think that's quite established in the industry now. That you have a lot of speech recognition, so you can dictate to your computer, and the computer will give you the written words. And the main thing that these things together, they can work sequentially. So we can have an audio that is transferred to text, and then the text can be understood by using natural language processing or any other way. So when you can do this. So computer vision as well. If you have a scanned document, handwritten document, the computer can understand it and then transfer it into text, and you can do some natural language processing on it to get more insights from that text. Neural networks. Neural networks is quite a topic that caused a problem within the AI and in the industry, in the data industry in general, because that caused what's called the AI winter, where people stop believing in AI. But currently, neural network is getting more attraction and is getting more reliable. So a neural network is basically you feed the computer some input, you have some hidden layers in between, and then you have an output. The hidden layers and that connects all the inputs to the outputs and assign weights to each of them. The main problem with neural network is understandability. So most of the people, they need to know how to interpret the outcome of these neural networks. So in simplest form, you have one hidden layer. Now there's a booming thing about, and it's a hot topic in the industry, also talking about deep learning. And deep learning, they add a lot of hidden layers, and then they add some filters like convolutional neural networks and or long short time memory, which can do some series or sequence analysis of these, and also it's used heavily in text analysis.